Hello dear viewers, how are you doing today? In this video, I give you a walkthrough of the code I have written for the homework of MLOps week 1. As a part of the course, students are required to complete a set of questionnaire each week and submit the answers. I will also show you how I set up the GitLab repository and push our code. Let us look at the code now. So I will launch VS Code first and connect to my WSL. Let's see in what directory we are. Okay, so I will create a directory called MLOps Zoomcamp homework. Okay, and I will navigate to this directory. Okay, now first of all, what I'm going to do is I'm going to create Conda environment for it, and I have some code snippets that I have copied in one of my Notion tabs that I'm going to copy paste. So I will call this MLOps Zoomcamp. Yes, let's activate this environment. Okay, now that the environment is active, I will now install pip, conda install pip. Yes. Now let's install IPython kernel. I will now install the kernel which will show in the Jupyter notebook. So replace it as MLOps Zoomcamp. Display name would be the same, MLOps kernel. Okay, let's call it MLOps kernel. Okay, kernel spec is installed. Now what I will do is create some folders connected to remote, MLOps Zoomcamp. I'll create some folders first. One folder will be required for input data. Second would be for the notebooks, right? And in this notebook, I'm going to have my first file. Let's call it week 1 homework eda.ipynb. Okay, we have the extensions here. Okay, so this is not installed in WSL, so I would click install all these extensions. In the meantime, let's go to the homework part and download the data. Use NYC, but instead of green taxi we'll use yellow taxi trips. Okay, January and February 2022. Copy link address. Now let's go to our terminal, ls cd data, and now let's download the January yellow taxi data. Okay, and we'll also download the data for February yellow taxi. Link address, I just want to confirm, but instead of green taxi, yes, it's yellow taxi and February 22. So this is downloaded. Now again wget shift insert, and this will get downloaded as well. Let's get back to our Jupyter notebook. Okay, so when I try to run it, it will ask me which kernel you want to use. So we had created the MLOps kernel while we were setting up the Conda environment. I'll select it. As expected, pandas is not installed, so I will install pandas. Pip install pandas. Additional packages are being installed. So I need to restart the kernel in order to use the updated package. Okay, I'll comment this package for now. Okay, so we have pandas. Initial goal was to show you a cell by cell execution of the Jupyter notebook, and I realized that it was difficult to organize the code and talk at the same time. So what I've done is I've completed the execution of the entire Jupyter notebook, and now I will explain all the cells to you. So this is a markdown cell that contains link to the homework guidelines, submission form, and the data source from which we have downloaded the data set, and also the data dictionary for it. So the problem statement for this particular homework is to predict the duration of taxi ride in minutes. Okay. In the last section of the video, you saw that I had installed pandas. When I further went to import the Parquet files, I received a couple of errors like PyArrow is not installed. So I installed this package, and for the machine learning part, I had also installed scikit-learn library. The next thing is I have imported this packages. Warnings is to suppress any warnings that might come as a result of deprecation warnings. And yeah, this is regarding the machine learning, dict vectorizer, and linear regression. So we will see their implementation in the cells below. When you import any data that has higher values, the data may get represented in scientific notation. To make it in a readable format, I have set this pandas display option. Okay, now I am reading the data set through this pandas command read Parquet. So this data frame January 2022, it contains the yellow taxi trip data for January, and this February data frame contains the data for February. Once we have that, I'm simply going to randomly sample few rows of the January data set and see here. Look at the columns. If I observe the columns, there are some columns which are related to tax, like MTA tax. Then we have tip amount, toll amount, improvement surcharge, so on and so forth, right? And if you look at the left hand side, there is some payment mode like cash, card, and then there is a location, pickup location and drop location. Another thing is some IDs which are not that important. Passenger count we have, right? Both the data sets are similar in nature. Now if we look at the information of the data frame, we see that certain columns like this is the trip pickup column which has the date format of date time, and also the trip drop off column is date time. There is no duration column if you look at the data set. So that is one of the next step that we are going to do. If we look at the described method of the data frame, we can see some statistical properties like count, mean, max and standard deviation of all the columns here, all the features. So what I have done is I have copied all the questions here from the form submission, and then I am proceeding to answer those questions. So the first question is, how many number of columns are there in January yellow tip taxi data. So I've used the shape function. Shape function gives us the number of rows and columns. So the index 1 here refers to number of columns. So this is our answer, 19 columns. Second question is, what is the standard deviation of the trips duration in January 2022 yellow taxi trip data? So as I mentioned before, there is no duration column, so we are creating the duration column here, and the way I'm calculating the duration column is subtracting the drop off time from the pickup time. And once I do that, I get the result like this. So I have noted an observation here. So it says that there are 0 days, and our problem statement is to predict the taxi ride duration in minutes. So what we are going to do is we are going to take the total seconds of this column and then divide by 60 so that the duration is in minutes. So this is what I do in the next step, right? And if we go back to our question, the question is calculating the standard deviation of the duration. So I use the pandas inbuilt function std and get the standard deviation here. The next question is, what is the fraction of records left up after dropping the outliers? Now, outliers in this case would be the duration column. It will be based on the duration column because there's no other column that can give us that quantitative level of distinction in which we can identify where the outlier lies. So I have implemented the describe method here, and once I do that, I see that the minimum value here is minus 3442. Something must be wrong from the data recorded here, and the maximum value is 8513 minutes. This is again very high value. This must be interstate or intercity travel. Anyways, what we can do is we can also look at the minimum level. For example, I can look at the 10th percentile and the higher percentiles like 0.95 and 0.99 percentiles. So when I do that, I get an observation that the minimum value or the 10% value is between 10 percentile value is 4 minutes and the 99th percentile is 50.85 minutes. So the way I'm going to skip outliers is I will take only those trips into consideration which are more than 1 minute and which are less than 60 minutes. Okay, so this way I filter the data, create a new data frame here, and I get the number of rows here, right? Now, in order to calculate the fraction of data points left after removing the outliers is getting the number of rows from this value divided by our original data set and then multiplying by 100. So it comes to around 98.27%, right? So the next question is, what is the dimensionality after one hot encoding? So what we'll do here is we'll pick up some integer or categorical columns and then transform them to string columns and then perform one hot encoding, right? So this is the code for it. So I have picked up two columns, the pickup location and the drop location ID, and there is also the trip distance which I am considering, but this is for taking into consideration the machine learning problem, right? So in these two steps I am converting the categorical data to string types, and once I have this data filtered, I will change it to a dictionary format and I will have them row wise. Once this transformation of the data is done, I will also initialize a dict vectorizer, right? And I will implement fit transform on the training data set, the training dictionary that we have here, and store it in the xtrain data frame. The target we have already calculated, it's the duration, and I will store it in this value. Next, I will have the values of the duration variable stored in the ytrain. Now, going back to the question, we are asked what is the shape of what is the dimensionality after one hot encoding. So I can calculate the shape, and I get the number of columns here, or the number of features or dimensionality is 516, right? And also I'm making a check here that the length of X train and Y train, they match. The next task is to train a baseline model using linear regression. We have already imported linear regression, and in the submission guidelines it is mentioned that we have to just consider the default parameters for this. So I'll simply fit X train and Y train that we calculated in the above cells. Once I have the trained linear regression model, I will use it to predict on the X train dataset that we have and store these predictions in Y predictions. The next question is to calculate root mean squared error on the training dataset. So from sklearn, I'm importing mean squared error. I'm specifying the Y train that we have from duration, right? And the Y prediction that we just used to get predictions on our train model. Setting squared equals to false gives us the root mean squared error value, and it comes down to 7. The next question is RMSE on validation set. So validation set here is nothing but the February data set that we had imported. It needs some kind of pre-processing that we had also done for our training data set. I am doing the same transformation of the validation set here, and once I have it, I used our previously trained dict vectorizer and used the transform method on the validation dictionary of the validation data set, which is stored in xval. For the validation of for the Y validation set, I'm getting the duration values and storing it in the yval variable. I use the predict method of our trained model and use it on the validation set and store the predictions in ypred. I use the mean squared error function again, but this time it is with the validation dataset and the ypred that we calculate here. Again, setting squared to false gives us the value of 7.79. The next step is to push the code to a GitHub or a GitLab repo. You can see that I have created a new account on GitLab and I'm going to host my project here. So after you have created your account on GitLab, you can click on create new repository, create blank project, fill in the details here, MLOps Zoomcamp 2023, fill out all these details. This I would keep as default, won't change. The deployment target will make the repository public, and I will also initialize the repository with a readme, and I will click on create project. You can't push or pull repositories using SSH until you have added a SSH key to your profile. So let's do that. So I will click on add SSH. So if you have never set up a SSH key before, there are steps mentioned in this link. So I'll click on it. From the navigation pane on the right hand side, click on generate an SSH key pair. Then we have this. So instead of comment, we can use our email address. So shift insert. Yes, pass. Once we have generated our key, we will add our SSH key to our GitLab account, and I would copy this command, which will copy it on the clipboard. Go to the terminal. Okay, so clip is probably not a part of it. So enter, copy the private key. Go to the SSH keys section of our GitLab account, paste those keys, click on add key. So we have added our a private key to our GitLab account. We have our keys added. We will go to our repository, and from this readme instructions we will set up our git. So we are already in our working directory. I'll copy the second line, open VS Code terminal, shift insert, not a git repository, okay. So git init, this we can change, then again shift insert. Now we have added here, right? And if we take a look at git status, there are no commits, so I will add first of all I will add a .git ignore file. I'm adding the git ignore file so that I can add the data folder to it. So if I go here, I can simply add the data folder, so data won't get pushed to our GitHub repo. Now let's check the status. Get status, let's add I will add a commit message, homework 1, homework week 1. That we have done the commit, let's go back to this instruction and git branch move force. So the master branch would be moved to main, and it's just command no such user. Okay, so the branch has changed, and the last instruction is git push force origin. So let's remote rejected. Okay, so we get an error, you are not allowed to force push code to a protected branch. So this is because of some restrictions on the branch we have. So let's find out what it is. If I go to settings and repository, protected branches, expand, allow to force push, we will enable this. Okay, once it is done, allow to force push. Okay, let's retry our command. Okay, track main from origin. Let's check our GitHub. Test this. Okay, so our notebook folder has appeared here. Yeah, so the push was successful. Let's just edit the file. I'll do that later. And once the push is successful, there is this form that needs to be filled in with all our answers. So that was the last step of this video. Thank you for watching.